Welcome to Kaarta Cloud, a new way to process, store, and share 3D spaces, taking you from capture to answer with a fast, convenient, and flexible workflow. Kaarta Cloud features an intuitive dashboard to manage all your data, scans, devices, and account information. Straightforward uploading and simple process management will increase productivity and free up devices for collection. Harnessing the power of Kaarta Engine, Kaarta's advanced mapping and localization algorithms, Kaarta Cloud processes raw Lidar data into a registered point cloud, providing a persistent framework to the data which can be further processed, manipulated, and now visualized in one multi-vantage environment. Currently, Kaarta Cloud can process data from 4 Velodyne sensors, including the PUC VLP16, PUC 32MR, Ultra PUC VLP32C, and the HDL32E. There are a few guidelines you should follow for the successful transfer and processing of your raw Lidar data in Kaarta Cloud. First, you need to generate a raw data bag file or PCAP file for your scan. Copy to an external drive, compress the raw files, and finally upload to Kaarta Cloud. The following provides guidance for each of these steps. To generate a raw data file from your Velodyne scanner, you can either use VeloView to log data for a PCAP file, or utilize the appropriate ROS driver for your sensor to produce a bag file. See the Velodyne website for more specific driver information at velodynelidar.com. A few specifics regarding PCAP processing on Kaarta Cloud and your Velodyne sensor settings. Prior to scanning, confirm or set the following parameters. Motor RPM, or the internal spin rate, should be set to 300 or higher, and the number should be a multiple of 60. Field of view, start should be set to 0 and end 359. The return mode of your sensor can be set to strongest, last, or dual during collection. However, if set to dual return, Kaarta Cloud only uses the strongest. Follow these pro tips for scanning and collecting data with your Lidar sensor to improve scan results. It is crucial to plan your scan route and devise a strategy for collection which will head off any unforeseen issues. Capture scenes with 3D structure. If scanning in an open area, take care to keep 3D structure in the field of view during scanning. Featureless environments will cause the scan to fail. For vehicle-mounted applications, mount Lidar horizontally with at most a 15-degree tilt up or down. Do not occlude the front or back of the sensor. Start data collection from a stopped position or a low velocity, less than 15 miles per hour. If data collections are started and stopped in the same place, Kaarta's self-correcting techniques and implicit loop closure can rectify for drift. For drone-mounted applications, try to fly below 60 meters above ground surface. Mount the sensor at angles up to 75 degrees. Fly smoothly and limit rotations to less than 30 degrees. After scanning is complete, copy your PCAP or bag file to an external drive. Select the file, right-click and send to a compressed folder if you are in a Windows environment, or simply compress items for a Mac. If you are running Ubuntu, use the zip command. Each scan should be contained in its own zip file. It's important that you do not include more than one file per zip. Before uploading data to Kaarta Cloud, become familiar with the major components of the platform by watching our onboarding video. This video provides detailed information about registering for Kaarta Cloud, creating an account, adding your Lidar as a device, making new jobs, and uploading data, all of which you will need to do before processing on Kaarta Cloud. Get up to speed at kaarta.com/resources. Once you've successfully uploaded your compressed raw Lidar data to Kaarta Cloud, the files display under the scanned assets of your job. Raw Lidar sensor data is denoted by a generic Lidar icon before each file. Right-click on the file to see options. Before doing any processing, you can share, download, rename, delete, or see the properties of the file. You must play back your raw data, BAG or PCAP, using the replay functionality in Kaarta Cloud before performing any additional processing. Right-click on the file and choose Processing Replay to display the playback window. To assist with sensor recognition, Kaarta Cloud will prompt you to select the Velodyne model used to collect data. Other parameter settings for replay include adjusting the time for playback to start or changing the duration of playback. The start and duration adjustments allow you to play just a section of your raw Lidar file. For replay of raw Lidar data, use camera must be in the off position to successfully process. For problem files, you can enable the Exclude Unlikely Matches and/or Difficult Environment Mapping Assist by turning the toggle to the on position. For a full list of replay settings, definitions, and scenarios, please see the Kaarta Cloud User Guide. Click the Proceed button and Kaarta Cloud starts the task. You are kept apprised of status in the user interface. Once replay has completed, the data has been transformed into a registered point cloud. Additional processing tools are made available, such as align, pre-filter, convert, filter, subsample, and visualization. The full spectrum of Kaarta Cloud's processing capabilities are discussed in our Kaarta Cloud processing video. You can find our tutorial videos at kaarta.com/resources. You can review your data prior to performing any additional processing or between each processing step by right-clicking on a file and choosing Visualization. Click Proceed at the Visualize window and Kaarta Cloud prepares your data for viewing. The View Asset button displays once the visualization has completed. Click to view the scan. The integrated Kaarta Cloud Viewer allows for point cloud renderings via a web interface, with a myriad of options for changing the appearance of your 3D data. Built-in tools provide ample measurement, clipping, and navigation functionality. For detailed information about the power of Kaarta Cloud visualization, see our instructional video found at kaarta.com/resources.